Welcome to the Math Record. Today I'll be covering the CCML Algebra 2 contest for 2019-2020 Division A. So I'll be going through every single question from 1 to 20, and if you want to solve a specific one or just find the solution how to get there, I'll put the timestamp for each question in descriptions below. And as I said for the Algebra 1 geometry for this year, I hope they don't copyright me on this because I don't know if it's fair use, but I'm just showing the solutions how to do it. Okay, number one. So 2 to the power of x minus 5 is equal to 128. So I don't actually have the documents, the contest, so I wrote in a doc on a Google Doc. So if you ever have trouble seeing it, I'll be writing on this blackboard. So 128 is just the same thing as 2 to the power 7, right? So 2, 4, 8, 16, 32, 64, 128, that's 7 of them. So x minus 5 is equal to 7, so x is equal to 12. And that's your answer for number 1. Pretty simple. Number 2, so matrix 2, 3, negative 1, 2 times negative 2, 0, negative 1, 0 equals ABCD, right? And we have to add ABCD. So we have to find the sum of the elements. So to do matrices, it's got to be horizontal or vertical. That's got to be our first one. Horizontal, vertical for the other one. It's going to be our B. Then this horizontal, vertical, then that's horizontal, vertical for C and D. So it's got to be negative 4, negative 3, so that's negative 7. 0, 0, so that's 0. So that's 2, minus 2, that's 0. And that's 0, 0, so that's 0. So that's A, B, C, D respectively. So the only element there that actually has a number is negative 7. So that's your answer, right? Because negative 7 plus 3 0 is just negative 7. Okay. Now ln of number 3, ln of, of y squared is equal to 2. So you could do 2 times ln of y because that's just log rules equals 2. So divide by 2, ln of y equals 1. So e to the power of ln of y equals e to 1. So y is equal to e, right? So if you kind of think about it, if you plug into this one, it's e squared. How else could we get e squared? Well, negative e squared, right? So that's e squared. So there's actually two possible answers, plus or minus e. And the reason is because when you actually kind of make a squared out here to bring it down, you actually, and it's even, you actually have to beat the ln absolute value. So then we divide by 2, that's 1. So absolute value of this. So e to the power of that is just absolute value of y is equal to e. So y equals plus or minus e, and that's your answer. That's another way to do it. Okay, number 4, solve for x. So 2 to the power of 2x plus 1 equals 2 to the power of x plus 3. Right, set them equal to each other. So that's x is equal to 2. Right? It's just basically just that simple. Okay. So number five, give the domain of the real value expression. Okay. The real value expression. So log of 2 minus x. Okay. So what we do is if you ever see the log of a graph, it kind of looks something like this. So it goes from 0 to infinity, but it never touches 0. So x has to be greater than 0. So what we could do is that now in this graph, that means log of 2 minus x has to be greater than 0 because that's inside the graph of the outside log. So the inside log has to be greater than 0. So that tells us raised to a power e, right? So if you raise both of these to a power of e, right, you're gonna have, oh, sorry, my tablet just died. Okay, e. That means you have 2 minus x raised to is greater than e to raise to power 0 is 1. So move the x to the side, so x has to be less than 1. And that's your answer. Okay. Number 6. A relation of R on the set S is cosymmetric if whenever order pair AB is in R, then BA also must be in R, where AB is the elements of S. If the relation 1, 1, 1, 2, 2, 1, 2, 2, AA is a symmetric relation on the set 1, 2, 3 to determine A. So symmetric basically means if you have 1 point like 1, 2 in here, then that means 2, 1 here. So you have to put the 2 here and the 1 here. So you have to switch places. So that's basically what it means. So that's why 1, 1 could exist because uh, if you put 1 here and you put this one here, that's just the exact same coordinate, so that works. So if you kind of look at this, if it's A, right, we need to find A, then the only thing that works since 1, 1 and 2, 2 is worked, then the only left is 3. Because when it says on the set 1, 2, 3, then you can only use numbers 1, 2, and 3. You can't go like 4, 5, or anything. So the answer is only 3. which you could logically think is the answer. Okay, number 7. Which of the following relations on the given set are symmetric? Write the capital letter of all that are symmetric. Okay, so basically, symmetric means that you if A is something to B, then B is also that same thing to A. So I'll go through every single one so you understand what I'm saying. So A, if A is greater than B, then B is greater than A. Well, that's not true, right? Because A is greater than B, then B has less than A. So this is not true. So this statement is false. So A is not an answer. Number B, if A is equal to B, then B is equal to A. That's true, right? Because A is equal to B, then B is equal to A. So B is true, right? So you see how this is done? And then we have parallel to, right? Line is parallel to. So if line A is parallel, so parallel to line B, then line B is parallel to line A. That is true, right? Because if two lines are parallel, then whatever way you put it, they're just going to be parallel. Okay, so let's erase this. So C works. And it's the same thing with D. If two lines are perpendicular, then whatever way you write it, they're going to be perpendicular because they're already perpendicular to each other. So D works. E is a parent of humans. Okay, so this doesn't work is because let's think about like A and B together, right? If A is the parent of B, then is B the parent of A? Well, no, right? B is a child of A. That doesn't make sense, right? If you think B is yourself and A is one of your parents or like your parents, right? Then if you're the child of your parents are not the child of you. That doesn't make sense. So E does not make sense, right? Because both of you guys cannot be the parent at the same time. So the only answers are B, C, and D. Okay. Number 8. Given the following complete graphs, what could be the graph of y equals e to the power of negative x minus 2 to the power of 2 plus e to the power of negative x plus 2 to the power of 2? So how do you, it looks really disgusting, but all you need to do is that you gotta look for those critical points. So x equals 2 and x equals negative 2. And the reason I'm saying they're critical is because they kind of have really special values here, right? Because they kind of seem exactly the same except this part. So what happens here? So when we plug in 2 here, that's going to be 0. So e to the power of 0 is just going to be 1. And then you put a 2 here, that's 4. And then 4 to the power of 2 is 16. So negative 16 is like 1 over e to 16. And the same thing happens here, except now this one's flipped. So this one's going to be 1, and this one's going to be e over 16. So when you add these together, it's just going to be 1. I know it's going to be 1 point like something, point something something, right? But this is so small, it's not going to matter. So it's going to be like 1.000 something. So it doesn't really matter. So the answer when these add up is 1. So you need to think about these. What does these points represent? So this is a quadratic, right? But it's quadratic concave down. So when you put the 2 in here, that's actually the center. That's the maximum point. So that tells us that when we put that point in, this value is actually going to become the max. Because if this is going to be increasing, right, just this section that's increasing, right, it's always going to be positive or 0. If it's going to be positive, then negative of that positive means it's just going to be 1 over e to the power of something. And that's always going to be really, really small. So the only way for that to ever be really big is when it's going to be equal to 0, right? So x equals 2 and x equals negative 2 make it 0. So it's going to be a 1, 1. So at x equals 2 and x equals negative 2, that's going to be a biggest point. So we're going to look at every single possible answer. So A, that doesn't make sense because negative 2 and negative 2 and 2, that's the lowest point. Doesn't make sense. B, well, they're not even the same point, right? Because when we calculate it, they're both 1. So B doesn't make sense. C, okay, that doesn't work because we said those were the maximum points, right? But they're looking at the graph, it could go even higher, right? So it's not C. D, well, that works, right? Negative 2 and 2, right? That's the maximum point. So D is a possible answer. E. Okay, that doesn't make sense, right? Because at negative 2 and 2, they have different values, but that's not true. They're both 1 at that value. So the only possible value for a possible graph for 8 is D. And that's just using these ideas of these critical points. Number 9, for the function y equals e to the power of x squared. Okay, and the values of x squared are plotted on the horizontal axis, while the values of ln of y are plotted on the vertical axis. What's the shape of the resulting graph? Okay, so let's take the ln of both these sides, so ln of y of ln of e to x squared. So ln of y, so ln of this is just x squared, right? So if we're plotting x squared over the horizontal and ln of y on the vertical, right? It just counts out really precisely. That tells us that if you kind of plot an x squared on the horizontal, that means you gotta substitute this with your new x, right? So it's just x by itself. and then substitute ln the y because that's going to become your new y values, right? So those are your y. So x equals y. What does that look like? Well, that's a line. So is the answer D? Well, actually, no, because you actually had to look at this. This is always going to be whatever number. So A could be whatever. It could be positive or negative, right? It's going to be some random number, right? So it could be positive but no negatives. Ln of y, it cannot be negatives, right? Because this is only positive. So this tells us that it cannot have any negatives in the values, right? So this doesn't exist. So it's only going to be something like this, right? So what does that look like? Well, that's a ray. So that's E. And that's the answer for number 9. Number 10. Okay, so, oh, sorry. Okay. So 2003 to the power 6 times 3, 1 equals AB. So there's actually a really fast trick to do this. So 2003 to the power 6. If you ever see something with two zeros like this, all you have to, or like it's kind of like the opposite way, it kind of, you could just raise it to a power. So it's just gotta be 2 to the power 6, which is 2, 4, 8 times 8 is 64 and 0. And then 3 to the power 6, 3, 9, 27. 27 times 27 is 729. Okay. And then 3, 1. Okay, so A and B, 64 times 3, that's 180, 12, 192, and that makes 0, so that's perfect. 0 times 3 is 0, 729 times 1 is 729. So we're looking for A plus B, so add them together. So that's 1, 10, 12, 1, 921 is your answer for number 10. Okay. Okay, so first 10 questions. Every single one should be kind of relatively easy, except for 8, which you have to think about, and number 9, right? So they're kind of like theoretical. Number 11, compute the determinant of 2 times, okay, so 2 matrix 1, 3, 2, 4, and that is raised to the power 5. So we need to find the determinant of this. Okay, so to find the determinant of this, let's just multiply 2 to these already. This is going to be 2, 6, 4, 8 raised to the power 5. So the determinant of this is just going to be the determinant of this raised to a power 5. That's just a property of it. So what's 2 times 8? That's 16. 4 times 6 is minus 24. I mean 24, so you have to minus because that's the idea of determinant, so that's negative 8. So then you have negative 8 raised to a power 5, which is 8 times 8, which is 64, and then multiply by 64 and multiply by another 8. So we're going to do 64 times 64 first. So that is 16, what, 24, 25, so 0. So 24, 2, so 36, 38. So we had 3, 8. Oops, sorry. I put the 0 down here, so that's a 6, then 9, and then 0, and then 4, 0, 9, 8. I mean 6, right? And then we're gonna multiply that by our remaining 8. Remember that's a negative, right? So we have to put negative. We need to stick a negative in here later. So this is 48, 72, 76, 0, 7. So then there's 32. That's 32. So 32768. Put a negative in front, and that should be your answer. Negative 32,768. Okay. Number 12. If y equals the absolute value of absolute y equals absolute value of x plus 1, so let's kind of plot that. So absolute value of a number of something is just a v. Since we had to add 1, we had to move it up 1, so it's something like this. And then y equals x plus 2, so we're gonna start at 2 because this is at 1, so it's a higher. And then it goes to, and it has the same slope, so it's like something like this. So the only time I ever cross is this section, and this one's negative x. So y equals negative x plus 1, and this one, and then the regular equation y equals x plus 2. So setting them equal to each other, that's 2x, that is negative 1. So x equals negative 1 half. So plugging in back into one of these equations, right? Let's say this one. So x equals negative 1 half. 2 is just 4 over 2, so 4 over 2 plus 1 minus 1 half is 3 over 2. And that's your value for y. So 12 is just 3 over 2. Okay. 13. Determine the degree measure of the obtuse angle made by the graph y equals 1 half absolute value x minus 1 half x plus 1. So if you kind of think about this, right? If x is negative, then both of these are going to be the same sign, right? Because negative, that makes this a positive, so it's positive this, and then negative, negative is positive, so positive, positive is 1. So it's going to have a slope of 1. But if they're opposite, they're going to cancel each other out, so it's just going to look like this. So if this is a slope of 1, that tells us that this angle and this angle are the same, and this is right triangle, so this is 45 and this is 45. So that means this is 135 because 180 minus 45 is 135. Okay, so that's a really fast question. Number 14, give all real solutions for 3 to the power of 2x minus 14 times 3 to the power of x equals negative 45. So we're going to treat this like a quadratic. So minus 14 times 3 to the power of x plus 45 equals 0. So 3 to the power of x and then minus 5 and minus 9. So minus 5, 3x minus 9 equals 0. Right? So that's 3x squared and then minus 9 and then minus 5 minus 14 and then plus 45. So perfect. So this one is log 3 of 5 and this one is just 2, right? So these are our two possible answers. Okay, so put a comma in between so they know what you're talking about. Log 3 of 5 and 2. And that's your answer for number 14. Okay, number 15. If x squared is equal to x to the power of x, where x is greater than 0, solve for x. So if you do log both sides, right, log of x, that's 2. And then x times log of x, right? And then we subtract from both sides. So, and then you can just shoot out the log x. So log x times 2 minus x equals 0, right? So then for this to equal 0, you just have x equals 2. And for this to equal 0, so log x, log 10, base 10 equals 0, right? So 10 to 0 is 1. So x equals 1, right? So those are our two possible answers, 1 and 2. Okay, good. Number 16. Willie and Joey are making fancy keychains to sell for a fundraiser. Little keychains cost four loops of metal, 4 grams of plastic, and 1 LED. Big keychains require 8 loops of metal, 4 grams of plastic, and 3 LEDs. The pair has 60 metal, 50 plastic, and 20 LEDs. Also, they figure out that small keychains cost $2 and large cost 5. What's the largest amount of money they hope to make? So, so the small ones cost 4 metal, 4 plastic, and 1 LED, so 1 L. And then the large ones, so let's call that big, right? It's already called big, sorry. And then there are 8 metal, 5 plastics, and 3 LEDs, right? And we have 60 metal and 50 plastic and 20 LEDs. So, and these cost $2 and these cost $5. So this question is just optimization, so it's just a bunch of trial and error. So how it kind of works is that we got a system. So 4s plus 8b, right? Because 4 of this and 8 of b equals less than or equal to 60. And then 4 of s plus 5 of b is less than or equal to 50. And it's just s by itself plus 3b is less than or equal to 20, right? So that's all we need. Let's delete this so we could just solve the system. So then we get some possible coordinates. Okay, so when we use the first and the second, right, that's just 3b is less than or equal to 10, right? Multiply with sign negative and add to the first equation. So b equals 10 over 3. And then that's 50 over 3. 50 minus 50 over 3 is just 100 over 3. Divided by 4 is 25 over 3, right? So this is like 8 and 1/3, and this is like 3 and 1/3. Right? So if you're rounding down, that's 8 and 3. So then we could use 8 and if we were rounding up, it could be like 9 and 3, and then 9 or 8 and 4, and then or both of them rounds up, which is 9 and 4. Right? But you gotta think about which ones work. So we put in 9 and 4 here, that's 9 plus 12, 21, so that doesn't work. We put 8 and 4 in here, that's 8, 12, 20, that works. 32, 20. Okay, so this one also doesn't work. Plug in 9 here, that's 36, 15. Okay, that doesn't work. So we could only use 8 and 3 for this one. Okay, so every single time you get a possible answer, try to check it with those 3 equations to see which ones actually work. So this one, oh sorry, I forgot what it was. It was 8 and 3. Okay, now first and the third. So times negative 4, so that's negative 12, so that's negative 4b. That's negative 80, so that's negative 20, so that's b is equal to 5. So b is equal to 5, plug into this equation, that's 15. 20 minus 15 is 5. So the next equation is 5, 5. Okay, so there's only one possible. Now use the second and the third equation. That is multiply this by negative 4, so negative 12, so that's plus the 5 is negative 7. Negative 80, so that's negative 30. So 30 over 70 is b. Okay. Now, if we put this here, that's 90 over 70. That's 140 over 70. So 140 minus 90 is 140 minus 90. Okay, that's 50. So that's 50 over 7, right? So 200 and 150. So that's 350 divided by 750. Yeah, that's 50. So this one works. So this is 7 and 1/7, and this is 4 and 2/7, right? So it's either 7 4, 8 4, 7 5, or 8. They both round up to 8 and 5, right? So actually, they both cannot round up, remember, because these are the minimum points, so we can't round up both of them, right? And we can't round up the individual ones either, so we can only round down actually on any single possible one. Sorry if I was misleading you for the couple of scenarios because you can't round up, right? Because it goes beyond the numbers. So plugging these three possible into our money, right? Because our oops, sorry, and because our because our small ones cost $2 and our big ones cost $5, right? So plugging that in, so that's 16 plus 15, that's 10 plus 25, and that is 14 plus 20. So this is 31, this one's 35, this one is 34. So the biggest is 35, so that's your answer. Okay. 17. If the system y equals mx plus 1 and y equals 2x squared minus 12x plus 22 has a unique solution for xy determinant. Unique solution means there's only one solution. So setting them equal to each other and subtracting, right? So mx plus 1 equals 2x squared minus 12x plus 22. So 0 equals 2x squared minus m plus 12x plus 21, because 22 minus 1 is 21, right? So the quadratic formula is negative b plus or minus, right? B squared minus 4ac over 2a. So there's only one solution if this part is equal to 0. So to do that, that means we have square root m plus 12 squared, or you have negative 1 and then parentheses m plus 1, m plus 12 parentheses, close parentheses squared. But negative 1 squared is just 1, so I just leave those out usually. And then minus 4ac minus 4 times 2 times 21. Okay. So this has to equal 0, so the inside has to equal 0 also. So that's basically just means m plus 12 squared minus this is equal to 0, so move that to the other side, so 4 times 2 times 21. Take the square root of that, so m plus 12 equals plus or minus, and then square root of 4 is 2. That's why I didn't multiply them out. So 2 times 21 is 42. So then minus the 12 from the other side, so negative 12 plus or minus 2 square root 42. And that is your answer. Right? There's both of them. You have to write plus and minus. So it's negative 12 plus 2 square root 42 and negative 12 minus 2 square root 42. Those are your two possible answers. Or you can just combine both like this, which is fine. Okay. Number 18. If the system y equals mx plus b and y equals 2x squared minus 12x plus 22 has a unique solution, determine the maximum value of b. So it's the same thing again. So y equals mx plus b and y equals 2x squared minus 12x plus 22. So setting them equal to each other and subtracting, I'm not going to do the work again, so it's just 0, 2x squared minus m plus 12, right? Remember what we did before for 17, it's basically the same thing, except now we're going to have 22 minus b, right? So b squared minus 4ac, so b squared minus 4 times 2 times 22 minus b. And this part is equal to 0, remember, right? So m plus 12 squared is equal to 4 times 2 times 22 minus b, right? So for this, now you have to think about this, right? Because this section is equal to 0, so then we got this part. So for this thing to have a unique solution, that means this section could only have one possible answer, and that would be equal to 0, right? Because if we have anything else, it could actually be plus and minus of that, right? If this is 1, it could be plus or minus 1, right? So the only possible is 0. So we have to set this equal to 0. So 0 is equal to 4 times 2 times 22 minus b, right? What can b be? Well, b has to be equal to 22 because 22 minus 22 is 0, and 0 times 4 times 2 is 0. So the only possible answer is 22. And that's your answer for number 18. And usually when you see questions like these, where it's mx plus b, the answer is just usually going to be the last term of that one. So you see the 22, just plug in the 22. That's your answer. Okay, but I just showed you the work of why that's true. Number 19. If a and b are not necessarily distant integers that are chosen from the interval 2 to 40, so it includes 2 and 40, what is the probability that log a and b is rational? So they are rational if they have the same base number. So what it basically means is that let's say you have log 2 of 4, right? Well, 4 is just 2 to the 2, so that's going to be rational that because that's 2 times log 2 of 2, right? Change it. We just move the exponent down. Or the reverse scenario is true, 4, 2, right? Log 4 is what 4 raised to a power 1/2, right? 2 to the 2 is just times 1/2 is just 2, right? So 4 square root of 4 is just 2. So it just they basically just need to have the same base value. So we're gonna have to write that out. So we have to write down all possibilities. So 2, 3, 4 goes with the 2, 5, 6, 7, 8 goes with the 2, 9 goes with the 3, and then 10, 11, 12. We're not going to put 5 and 10 together because 10 is 2 times 5. They're not the same base as just 5. There's two bases here. So there's 13, 14, 15, 16 goes with the 8, 17, 18, 19, 20, and then 21, 22, 23, 24, 25 goes with this one. 26, 27 goes with the 3, right? Because that's just 3 to 3, right? And then 28, 29, 30. And then 31, 32 goes with the 31. And then 32 goes with this one, so. And then 33, 34, 35, 36. 36 goes with the 6. And then 37, 38, 39, and 40. Right? So if we had to choose two numbers here, they could be the exact same. So you could choose like 2, 2, 2, 4, 2, 8, 2, 16, 2, 32, or 4, 2, 4, 4, 4, 8, 4, 16, 4, 32. So how many combinations can we make that? Well, the first number can have has five possible choices, 2, 4, 8, 16, 32, right? So A has five possible choices, and B has five possible choices, 2, 4, 8, 16, 32. So 5 times 5 is 25. So we could do the same logic for every single one. So it's just that number squared. So there's 5 here, so that's 25. There's 3 here, so that's 3 squared. That's 9. 2 squared is 4. 2 squared is 4. And now every single 1 is just 1 times 1, which is 1 squared is just 1. So you just add how many there are. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. Right? Add them together. So that's 8, that's 17, that's 42. At this one is 69. So we have 69 total. Okay. Remember that number? Because that's the total of combinations that work, that are rational. So how many combinations are there in total? Well, the first number has 39 choices, right? 2 to 40 is 39 numbers. And then the second number has also 39, right? So then this simplifies, divide by 3, that's 23. Divide by 3, that's 13. So now we need to simplify from the top and bottom. So 39 times 13, that's 27, 9, 11, and then 0, 3, 9. So that's 507. And that is your answer for number 19. 23 over 507. Number 20, rhombus MEOW where angle M is equal to 135 degrees. If a point is randomly chosen for the interior MEOW, what is the probability that it's closer to M than any other vertex? Okay, so we have something like this. M, E, O, and W. Cool. So if this is 135, then this is also 135 because vertical angles are the same. I mean, opposite angles are the same for a rhombus. And then to these angles, when you add them together, it has to be the same. So that's 45 and that's 45, right? Because 180, 180. Perfect, right? Because opposites are the same. So that is going to be our angles. So it's going to come back later. We just need to worry about the 45. The 135 actually doesn't matter. So you're going to split this up as a grid to see how that works. Because if we have to choose a point in here, how is it closer to M than any single other point? Well, if it ever crosses this line, then it's actually closer to O than actually M. And the reason is because if we at this point, then it's equidistant to each other, right? So if it's here, then it's gonna be close to M. If it's over here, then it's close to 0. So none of these points in this section work. Okay. So now how do we get is closer to M than E or W? Well, E or W are basically the same thing. So let's just focus on one side. Let's see E. right? So if we make a perpendicular bisector, right, because a bisector gives us our distance are the same. So we draw a perpendicular bisector, right? Perpendicular. The side length is equal to the side length. So if you ever think about it, right, if it ever crosses this line, then it's closer than E to M, right? If there's a point here, it's closer to E to M. And the reason is because if you kind of think about it, whatever point is on this line, it's always going to be equidistant to each other because they have the same height and the same length as the base. So if it ever crosses this line, it's going to be closer to E than to M, right? So we just need to find the area of this. In the same case here, perpendicular bisector. And since they're the same length because it's a rhombus, then these two areas are basically the same, right? So let's set all these length to 1. So this is 1 plus 1 is 2 on this side, right? So what is this side length, right? Because we have to use with this triangle, because I would draw this out for you. Let's just use one of these triangles. Okay. And our perpendicular bisector. So this is 1, this is 1. And the reason we need to find this side length is because they share because oops, let's put the right angle right here. And then there's a right angle here, and that's 1, 1. Right? So they both have a right angle and they both share this angle. So that tells us that this triangle and this bigger triangle are similar. Okay, so we need to find this side length so we can find the proportion of this area to the actual triangle, subtract that away from the bigger area, from the bigger triangle, and then we get this area. Okay, so that's going to be our plan. So we know this is 2, so this is 45 degrees, so that's why I said the 45 is important. So we're going to use something called law of cosine, which states the opposite angle length of that side length of that angle, we could calculate. It's just the formula is c squared, so let's call that side length c. So c squared equals a squared, which is 4, and then this squared, which is also 2, so that's also 4, minus 2ab, so 2 times 2 times 2 is 8, times cosine of 45, because that's their angle. So cosine 45 is square root 2 or 2. That's just the law of cosine. C squared equals a squared minus b squared plus b squared minus 2ab cosine of the angle. Okay, so if you don't know it, I recommend you knowing it in law sign. So this is just gonna be equal to square root 4 plus 4 is 8, and then divide, and then that's 4 square root 2. Okay, so we're not gonna simplify this part. So c is this entire length. We want half of it, right? So half of this. So half of this outside is also 1/4 inside. So that's gonna be, so this side length is gonna be 8 divided by 4 is 2, and then 4 square root 2 divided by 4 is minus square root 2. Perfect, right? Now how do we get? Now we need to get this side length, right? So how do we get that one? Well, that one's also kind of simple because this one is just a right triangle, right? So you can use the Pythagorean theorem. So a squared, so 2 minus 2 equals, let's call that side length a, I mean x, so plus x squared is equal to 2 squared, which is 4. So minus and minus that side, so that's just 2 plus square root 2 square root. Okay, so this entire length is 2 plus square root 2. And now we can use our similar triangles now, because now we have everything. So if you kind of think about it, this angle and are the same because they share, and then this right triangle is right triangle. So this side length actually corresponds with this side length. So the proportion of the area is 1 over square root 2 plus square root 2. Right, so we're not going to simplify this further yet. And then if that's our relationship between a side length, then our area is going to be squared that. So it's going to be 1 over 2 plus square root 2. Right? So that's our ratio of this to the entire triangle. Now to find that this area now, we just have 1 minus that. So 1 minus this number is 2 plus square root 2 minus the 1 over 2 plus square root 2. I just don't have room to write it. So that simplifies down to 1 plus square root 2 over 2 plus square root 2. Okay, and that should be the area. I mean, that should be the ratio of this area to the entire triangle. So what's the entire triangle's area? Well, it's just base times height times 1/2, right? So that's our base times our height, so 4 minus square root 2, right? It's just this side length times a half. And that's why we found it. So 2 times 2 is 4, 2 negative square root 2, and 2 square root 2. That's the same numbers, but different signs, so they cancel each other out. Square root 2 times square root 2 is 2, so minus 2, so 4 minus 2 is 2, so it's just going to be 1/2 times square root 2, which is just square root 2 over 2. So the area of this triangle is just square root 2 over 2. So multiply that ratio by square root 2 over 2 to get us the area of this. right? So we're not gonna simplify just yet. So square root of 2 times 1 is square root 2. Square root of 2 times 2 is 2. And then 2 times that number is, let's just put 2 plus square root of 2, right? So that looks pretty messy right now, but it will simplify really well later on. Okay, and that is the area of one of those sections, right? That's the area of just this one. We did all that work so we could find this area. So there's two of them, right? There's one here and there's one here. So to get the other, the total area, just multiply 2. And that's why I didn't distribute out because those cancel out. So now we have square root 2 plus 2 over 2 plus square root 2, right? So if we rearrange this, denominator is just square root 2 plus 2. Square root 2 over 2 plus square root 2 plus 2 over square root 2 plus 2. That's just 1, right? So the area of both those is just going to add up to 1, okay? So each of those area individually is just 1/2, okay? So what we could do now, since we know the area is 1, what's the area of this entire shape? Well, remember this triangle, it was square root 2 over 2, right? Since there's 4 of them, just multiply by 4. So multiply that's 2 square root 2. Okay, so the ratio, so it's a probability, it's just that area that works over the entire area, which is 2 square root 2. And simplifying this, multiply by square root 2 on the top and bottom. So square root 2 is on the top. And then square root 2 times square root 2 is 2, times this 2 is 4. So your entire thing is square root 2 over 4. And that's your answer for number 20. Okay, and that basically covers every single question. Well, thanks for watching, and I'll see you at the next math record.